Okay guys, latest update, just a reasonably quick one. I've added 2 more caps. That's for some reason lifted our voltage up about another volt on our voltage doubler. The caps are just in parallel, not in series. We've gone down to a small transformer, as you can see there, 500 milliamp, 12 volts. I've had to take it apart. I ripped the rectifier and the capacitor out of it because it was a DC output. We want AC, which we now have. Got our little meter there, reading 0 of course, nothing plugged in it, so not drawing any watts. I'll plug the transformer in, and our transformer is drawing 1.3 watts. Through impedance losses in the transformer itself because it's still not hooked up. Cap's only got 4.37 volts in, 12.68 volts AC from our little transformer, so we've gone down in voltage a little bit on the transformer. I think the last one was about 13.4 volts. This one here is going to be our current going to our charged battery, and of course our charged battery voltage. I stuck a globe on it for a little while, pulled it down a bit. It seems to have rested at 12.64. Tidied all this up, gone thicker wires. I've put 3 4007s in there. SD done it on his and gave him a bit of an improvement on the current. I've also got another one here going to this white lead, which I'm just going to plug on this bit of plastic here for the time being out the road, and I'll show you what that's for a bit later on. So anyway, what I'm going to do is hook the transformer up now so we can get some power into it. Of course, pumping up the caps, our wattage will go up, so I'll hook it up now. Coming down, filling up the caps, back to our 1.3. Okay, the caps are full. Still 12.68 coming from the transformer. We now have 34.6 volts in the caps. So by adding 2 more caps, our voltage went up about 1 volt than it was before, and a lower voltage from our transformer. So there's definitely something with the amount of capacity that you've got in caps that affects the voltage doubling. We've got roughly 10 volts more than what we should have. But anyway, what I'll do, I'll start up now. Like before, end of the trigger wire, which is this one here, going straight to the base on the transistor. I'm coming, sorry, that's the start of the trigger wire. Coming out of the end, second winding, so we're only going to be running on 2 out of the 4 windings for the trigger, because that's plenty enough. Through the resistor, through the pot, and then back into the emitter. So back to front, but seems to work quite fine. I'm not sure if it has anything to do with what's going on here, but anyway, so we'll start her up. If I can, I've got to spin it pretty quick to get it going now. There we go. So what I've found is about 150 milliamp draw. Get it settled at that. Seems to be the best conversion rate. Turn it up a bit more. I actually think I've damaged the pot because you only have to touch it with the fingers and everything changes. jumps around very erratic by the slightest movement, so I think she might be toast. When I had it hooked up to the first one, so I'll have to change that. But anyway, we're pretty close there. Still speeding up slightly, so it's going to change a little bit. But between 150 and 160, drawing the cap seems to be where it's happiest. We've got 30.95 volts. We'll say 30.9 volts in our cap. And like I said, it's still only just have to touch that. That's definitely toast. So 30.9 at 153 milliamps gives us 4.7 watts of power that we're actually pulling from those caps at the moment. However, we're only pulling 3.9 watts from the transformer to fill those caps or keep them charged. Now, keeping in mind 1.3 watts of that was through losses in the transformer itself. So if we take that into account, that's even better. So I think she's just about settled. Okay, so 4.7 watts coming out of our caps. 3.9 watts going in minus our 1.3 watts loss in the transformer itself. So you can do the math, take it off if you want. To get a true reading you'd have to do that, or you can leave it on. Either way, we're still pulling more out of those caps than what we're putting in. So that's good in itself, but also we're charging this here battery at 79 milliamps at 12.73 volts. So we could do a wattage calculation on that. Won't be quite right because we have to go on rest voltage, not charge voltage, but it'll give us an idea. So if I just go 12.7 times our milliamps, 0.079. So that gives us 1 watt as well. So that 1 watt we could take off of that as well, because we're getting that back out of the system. So the 1 watt plus the 1.3 through losses in the transformer gives us 2.3. That would bring that watts down to what, 1.6 watts being fed into those caps. And at the moment I'll just do a recalculation. 30.9 times our 156, 4.8 watts. So, like I said, even without taking the battery charge into account, got 4.8 as opposed to 4 going in minus the 1.3 would give us 2.7 watts going in for our 4.8 coming out. Then you can also take the extra watt that's being put into that battery off of that 2.7, which would make it a 1.7 watt usage for a 4.8 watt current coming out. So that's it up to date. Do the sums yourself. 30.8 in the cap, drawing 159 to run the motor. 4 watts there, minus the 1.3 to the losses in the transformer, and we don't even have to worry about adding that up because we're already coming out in front. Okay, second thing, this one here, what I'm going to do is take it off of here and I'm going to plug it straight onto the positive of the cap. When I do so, I'm going to put that on there. Watch our watt rating. 3, 2, 1. So we're down to 2.8. The voltage is 32 point. We're going to go 32.1. 253 milliamps. Oops, 32.1 times 0.255. 8.1 watts now coming from those caps. 2.8 watts including the transformer losses being fed into those caps. Now the only thing by doing that, of course the motor wants to draw extra 100 watts of power because it's pushing the power back in. The other thing that happens is the battery charge is no longer. So when I take our return voltage back off, our charge goes back up and our amp draw goes back down and our wattage goes back up. So this thing does all sorts of strange stuff, which I don't as yet have any answers for. But as you've seen, we're definitely pulling more off of those caps than what we're putting into them, as well as charging a battery. And we'll feed the power from the spikes back into the caps. The wattage that's charging the caps from the transformer goes down, and the amps that it takes to drive the motor at those volts goes up. So I have no answers for that. So I might just leave it up to you guys to ponder on, see if you can work out what's actually happening here. I'll post it as soon as I can and look forward to your comments. Cheers from the Tin Man.